Find the x-intercepts and y-intercepts of the graph of the equation x minus 3 squared over 9 plus y minus 2 squared over 16 is equal to 1. Express your solutions as ordered pairs. If you've been reading in the notes, you will recognize this as the graph of an ellipse that is centered at the point 3, 2. But you really don't need to know that to work the problem. What we want to do is we want to find the x-intercepts, and the way you do that is you set y to 0. And we also want to find the y-intercepts, and the way you do that is you set x equal to 0. So let's start with the x-intercepts. Setting y to 0, here's what we have. So in this step right here, y got set equal to 0. Now we'll skip a few steps. You can do a lot of this in your head. 0 minus 2, well, that's a negative 2. And negative 2 raised to the second power is positive 4. So we have 4 divided by 16, and 4 divided by 16 in lowest terms is 1/4. So let's start with that. Remember, we're trying to solve this equation for x, so we want to take this 1/4 and move that over onto the right-hand side. The way you do that is by subtracting 1/4 from both sides of the equation. When you subtract 1/4 from the left-hand side of the equation, you get x minus 3 squared divided by 9. When you subtract 1/4 from the right-hand side of the equation, you get 3/4. The next step in solving for x is to multiply both sides of this equation by 9. And when you do so, you get x minus 3 squared is equal to 27/4. The next step in solving this equation is to take the square root of both sides of the equation. When you do so, you get x minus 3 is equal to plus or minus the square root of 27/4. Finally, the last step to solve this equation for x is to add 3 to both sides of this equation. And when you do that, you get x is equal to 3 plus or minus, and I could write 27/4 here, but this writes a little more neatly as the square root of 27 divided by 2. Now, up in the problem it says express your solutions as ordered pairs. We've got 2 different x values here, so the x-intercepts here will be the first one of those, which is 3 minus the square root of 27 over 2, comma 0. That is one of the x-intercepts. And here's the other x-intercept. It is 3 plus the square root of 27 over 2 and 0. So those 2 right there are my x-intercepts, and I found those by setting y equal to 0. Now, to find the y-intercepts, I need to set x equal to 0. So I go up here and I set x equal to 0, and that makes the equation look like this. Now, in this particular case, we can do a little bit of this in our heads. If you take 0 minus 3, that's a negative 3. And a negative 3 squared is positive 9, and 9 divided by 9 is equal to 1. So I'll go ahead and write that down. 1 plus y minus 2 squared over 16 is equal to 1. Now the next step in solving for y, which is what we want to isolate, is to subtract 1 from both sides of this equation. So when you subtract 1 from the left-hand side, you get y minus 2 squared over 16. When you subtract 1 from the right-hand side, you get 0. The next step in solving this equation is to multiply both sides by 16. When you multiply the left-hand side by 16, you get y minus 2 squared. When you multiply the right-hand side by 16, you get 0. The next step is to take the square root of both sides. When you take the square root of the left-hand side, you get y minus 2. When you take the square root of the right-hand side, you get plus or minus the square root of 0. But the square root of 0 is 0, and plus and minus 0 are the same number, so this is just y minus 2 equals 0. Last step in solving this equation is to add 2 to both sides of the equation. When you add 2 to the left-hand side, you get y. When you add 2 to the right-hand side, you get 2. So finally, to express the solution as ordered pairs, there is only one y-intercept, and it is 0, 2. So again, with the ellipse centered at 3, 2, strikes the x-axis at 2 points, and there they are, and then it just comes in and just barely hits at 1 point the y-axis, and that y-intercept is 0, 2.